My name is Kianoosh, and I'm currently at Columbia University working on ocean waves. I obtained my PhD from University of Delaware, and I'm studying in general for the fundamentals of ocean waves and the turbulence and turbulent flows above and below ocean surface. So, about two-thirds of the surface of the Earth is covered by the ocean, and the exchanges of momentum, energy, and heat over such a huge area between the atmosphere and the ocean play an integral role in determining the sea state and weather patterns and climate, and that has significant impact on different aspects of human life. However, the current model predictions are far from satisfactory. For example, in the last 10 years, uh, the overall in total extreme weather events in the US only cost about $930 billion worth of damage and lives of about 5,400 people. In fact, the current parameterizations of these model predictions are limited, and for example, that prevents us from making accurate prediction of tropical storms and hurricanes. So my work in general is focused on turbulent flows and how ocean waves are impacting these turbulent flow above and below the ocean, and the surface waves and the corresponding generation of turbulence, bubbles, airflow separation, breaking waves, and spray. So uh, during my PhD and postdoc at Columbia at University of Delaware, we performed a set of experimental measurements and to obtain the airflow velocity and see how surface waves and especially wind waves are affecting these momentum and energy balances. And currently at Columbia University, I'm using these data sets to develop a numerical parameterization, a numerical model to be a specific a wall layer model for use in large eddy simulation. So we are using two different approaches. Like the first one is that we are using a dynamic surface roughness modeling for LES, and that's it's like we just considering two different scales for large eddy simulation, and the assumption or the fact that the surface stress or the drag at the surface of the ocean is not changing across the scales. The other approach is that we are taking these experimental data that I mentioned and use it as to train a machine learning algorithm and develop a machine learning surrogate model for using large eddy simulation. So these methodologies actually can help to reduce the amount of computational costs for predicting the surface drag and can enhance the numerical results and parameterizations of large eddy simulations.